Good morning. Today is the 20th. And today we're going to cover actually the final lesson in Chapter 5 that we are going to cover, which is Lesson 5-4 on the triangle inequality. So you saw several inequalities in yesterday's notes, but this one is actually called the triangle inequality. So it's actually a theorem. It's called the triangle inequality theorem. And here's what it says. The sum of the lengths of two sides of a triangle is greater than the third side. Okay, so to give you kind of a visual, let's say I have triangle ABC, as always. So what this basically means is that if I were to take any two sides of a triangle and add them together, that amount has to be greater than the third side. So if I say like side AB plus side BC, that has to be greater than the remaining side, AC. It can't be equal to it, it has to be greater. And it has to work for all of them. So like if I say BC plus AC, that has to be greater than AB. And then the third combination would be AB plus BC, that has to be, no, I lie. Let's fix it. There we go. AB plus AC, that has to be greater than BC. Okay, otherwise the lengths cannot form a triangle of any kind. Okay, so that's really the basis of this entire lesson. So let me show you how this is going to work, or what it's going to look like as far as examples. So here's the first one. It'll say something like, can the given lengths be sides of a triangle, or something like that. Okay, and then it'll give you some lengths. So we'll use easy numbers. How about 1, 2, and 3? Okay, so what you need to do is say, okay, well, if I take each of these, like if 1 plus 2, is that greater than 3? 2 plus 3, is that greater than 1? 1 plus 3, is that greater than 2? Well, you should have noticed right away with the first one, 1 plus 2 is not greater than 3. It's actually equal to 3. Okay, so in this case, no, because 1 plus 2 is not greater than 3. So I just take a greater sign and just cross it off to show that it's not greater than. Okay, how about this one? 8, 8, and 15. So we have an isosceles triangle. Okay, so always check. 8 plus 8, is that greater than 15? Yep, it's actually 16. 8 plus 15, is that greater than 8? Yep. 8 plus 15, is that greater than 8? Yep. So these can form the sides in a triangle. Okay. How about this last one? 18, 32, 21. Okay. 18 plus 32, is that greater than 21? Yes, it is. 32 plus 21, is that greater than 18? Yes, it is. 18 plus 21, is that greater than 32? Yes, it is. So these can form the sides of a triangle. Okay, so that's one way you're going to see these problems presented. The other kind of problem, or another kind of problem, would be something like this. Find the range of lengths. Find the range of lengths for the missing side. So for these, you're going to see two lengths, and you got to figure out, okay, well, what are the possibilities for the third side? So let's say we have 5 and 11. Okay, well, there are actually a lot of numbers in here because we could even do like decimals and fractions and all that kind of thing. Okay, so here's what we're going to do. In order to figure out the lower boundary, okay, the lowest number that it can be, we're going to take 5 and 11 and we're going to subtract them. Okay, so, I mean, it has to be positive, so, because you can't have negative length. So 11 minus 5 is 6. So anything that we have cannot be lower than 6. Otherwise, it's not going to work. To find the upper boundary, you're going to add these together. Okay, so 5 plus 11 is 16. So it can't be bigger than 16. Otherwise, it won't work. So we're actually going to write this as an inequality. So x has to lie, x meaning the missing side. X has to lie between 6 and 16. It can't be equal to 6 or equal to 16. It has to lie in between there. Okay, so that way we've accounted for all the possible decimals, all the possible whole numbers, all the possible fractions. Okay, so let's try this again just to practice. So let's say we have 21 and 47. Okay, so again, we want to figure out the range of lengths. Okay, so 21 and 47, to get the lower boundary, we're going to subtract them. 47 minus 21 is what? 26. Then to figure out the upper boundary, we're going to add them. So 21 plus 47 is what? 68. Write it like an inequality. So x can lie anywhere in between there. Okay. So that's the second kind of question you're going to see. The third kind, because it wouldn't be a geometry lesson if we didn't have the distance formula, would be something like this. Determine whether the given coordinates, so determine whether the given coordinates are the vertices of a triangle. Okay, so for this one we have vertex A, 5, 8, point B, 2, -4, point C, -3, -1. And no, if this was on a test or a quiz, you cannot just graph it and show me. You have to use the triangle inequality to show me, so you have to compare the lengths of the sides. Okay, so we need to find a side AB, we need to find a side BC, and we need to find a side AC, and then compare those lengths using the triangle inequality. Okay, so let's do AB first. Okay, so we have 2 minus 5 squared plus -4 minus 8 squared. Okay, so 2 minus 5 is -3, careful with the negative. -4 minus 8 is -12, careful with that negative. So now when you square it, you get 9 plus 144. Okay, so that's going to give you the square root of 153. And for the purposes of this, it actually might be easier to put it in a decimal, just so that we can compare it. So this one is going to be, oops, let me get my calculator so I can get an exact decimal here. About 12.37. Okay, just give us an idea. All right, let's do BC. So BC, negative 3 minus 2 squared plus negative 1 minus negative 4 is like plus 4. Okay. So we have negative 5 squared plus 3 squared. So that would be 25 plus 9, which is the square root of 34. And as a decimal, that would be about 5.83. Okay, let's see what our third side is. So AC, negative 3 minus 5 squared plus negative 1 minus 8 squared. Okay, so we have a negative 8 squared plus a negative 9 squared. So that would be 64 plus 81. And that would be the square root of 145. And the square root of 145 is about 12.04. Okay. So now we need to compare these and see if they follow the triangle inequality. Okay, so 12.37 plus 5.83, is that bigger than that? Yes, it is. 5.83 plus 12.04, is that bigger than this one? Yes, it is. 12.37 plus 12.04, is that bigger than this one? Yes, it is. So to answer our question, determine whether the coordinates are the vertices of a triangle, we say yes. Okay, so that's the triangle inequality. Your assignment is written on the board. Feel free to rewind any part of this video if you need it repeated. Tomorrow, plan on a review, and then Friday will be your quiz for this short little chapter. Have a great day.